Hi Jay, very good morning. Yeah, this is so good and
Yes.
it's a beautiful day. So now this is our third session,
Yes, sir.
a third day of
Yes, sir.
great session. So this will be very good. Let me just set a few things quickly.
So next session will be taken by Prashant, right?
After this,
Yes. Very good morning, everyone. It's very nice weather here at IIT BHU, and this talk is all about data analytics and predictive technology from 9 to 10:30, and we are pretty much fortunate that this talk would be taken from our organizer itself, Dr. N.S. Rajput sir itself. I think you will learn a lot out of it. So let me introduce Professor. Dr. Naveen Singh Rajput is an associate professor in the Department of Electronics Engineering at Indian Institute of Technology, BHU, Varanasi. He has established the R&D and Technology Extension Laboratory for Network Communication and Computation NCC lab to support advanced system for IoT, CPS and robotics apart from many other key central facilities. He is the recipient of Ministry of Human Resource Development MHRD Government of India prestigious national award Teaching Innovator Award. He is the recipient of IBM Faculty Award for $10,000 and the NVIDIA hardware grant worth $5,000 for the development of India's first Swachh Bharat, actually Clean India Android app. He is also member of National Supercomputing Mission NSM, Government of India, and Indian Grid Certification Authority for access to national and international supercomputing grid and nodal officer and national knowledge network. His research interest includes the design and development of smart sensors and system in the IoT and CPS paradigm for smart city solution, especially gas sensing system, advanced precision agriculture system, and robotics. He has authored the book Blockchain for Smart City Application, and it's appeared in 2020, published by Springer and Nature. So I'm not going in more detail like the publication of journal conferences. Obviously, you have, sir. So okay. So thank you so much for being so wonderful coordinator, actually. And we are delighted that at least you are taking one session out of it. Thank you so much. Now stage is yours, sir.
right, right. Thank you very much, Dr. Ajay. In fact, the introduction has already been quite elaborate. So, so good. Thank you very much for the honors. Okay, so I think we can start with very basics of the things. Okay, so hello, good morning, everyone. I am Dr. Rajput from IIT BHU from Department of Electronics Engineering, and I have already also shared my WhatsApp number, social contact number, as well as the Telegram number. So feel free to send me any number of messages, and feel free to interact at any point of time wherever you need. Okay. So with this thing, we will come to our basics, what we intend to discuss. So we have data, we have analytics, predictive, and technologies, right? So data analytics and predictive technologies is the today's prerogative to talk about. So I will start with very pinpointed things. What exactly are data analytics and predictive technologies? Okay, so of course, when you will go on the internet and if you will find the basic detailed definition of what data analytics and predictive technologies can be, I would look forward to explain it in a different way, which you can consider as a simple thing. So data is I would call digital data, and when the data is digital, you know the world is from analog world, right? So technically speaking, there is nothing like digital data. The world is analog, so you are observing analog world, convert it to digital data, right? So while we generate data, how do we generate data? So for that we will require data generation system, and that will be sensors, right? And the sensors can be analog as well as digital. If so, you have analog world, and this analog world goes into sensor or transducer. So the sensor or transducer will actually be a device or mechanism which will actually sense the analog signals, convert one form of energy into another form of energy, and then this is forwarded to the processor or the controller. We will discuss about that just now. Basically, sensor phenomena with which it will convert will also be analog, right? So the phenomena is sensed. Once it is sent, this is sent to analog to digital converter. So when it is converted into digital form, you will get digital data, right? So that is the main thing. The whole world is basically digital, and from the digital world we generate the world is analog. From analog world we generate digital data, and digital data is then accordingly fed to a controller, or a processor. By controller I mean microcontroller. So microcontroller and processors are two different platforms. One will have operating system, one has been designed for general purpose applications. Microcontrollers are also designed in a general purpose manner, but they have limited capabilities, but they have a very specific possibility to write programs, execute things of the similar nature, whereas the processor is a program based things, and it runs various loops. A microcontroller reiterates the same operation or procedure after every intended delay period. So accordingly, the controllers will receive digital data from here, right? And this digital data is getting into from sensor, right? So sensor is getting converted, sensor responses are getting converted into digital form. Controller is capturing this data from its pins. So we have multiple pins. We write them as analog to analog or digital pins. Digital pins are the ones which will only receive digital values, right? In analog pins, it receives analog signals directly whereas internally it is equivalently converted into some digital value, right? So in that way, usually suppose if it is 8-bit A to D converter, then 2 raised to 8 will be the levels, right? Similarly, if I have 10-bit or 12-bit A to D converter, this will be 2 raised to 12, right? So number of levels. Now, this controller is operated from at a value of say plus 5 volt DC. So this is the highest value which can be fed at this pin. So this will be from 0 volts to 5 volt DC, right? And this is broken into 2 raised to 8 levels, or 2 raised to 12 levels, or 2 raised to 10 levels, or whatever is the specified A to D specifications used in a particular controller. We have Arduino controllers, we have different other PIC controller, we have controllers from Texas Instrumentation, the instruments. Also, different brands offer different types of hardware configurations, and they are used. And accordingly, suppose you are feeding, say, feeding at analog pin some 2.4 volt. So internally, this will be placed somewhere here, right? 2.4 volt, uh, 2.4 volt, and this 2.4 volt will be equivalently converted. Suppose if it is in 8 bits, so maybe 001011110, right? Kind of. So some equivalent digital value will come, and this controller will have libraries to convert these values, these serial the values into workable integral numbers, right? So in integral numbers that will be used. So what we understand is, from analog world we generate digital data, right? Digital, once it has been converted into digital, now you can process, right? The process is actually the analytics. What kind of data is being generated and how to analyze that data. This data can be realized in both versions. It may be in real time, it may be offline analytics, right? So when we talk about a sensor network or sensor system, there will be n number of such sensor nodes which will transmit their data. So usually we understand that storage is in cloud. A cloud can be private, maybe some some industry is running its own cloud. It may also even run this facility not on the cloud but on remote server, right? So they may have their own private network, they may have their own private storage. So this is where they can collect the data in real time or in near real time, depending upon what kind of operation they are trying to monitor. Now, whatever data is being gathered, maybe this data has been gathered for the last 1 year or 10 years, or maybe every minute you are monitoring some process. So in this way, lots of data is getting into it, right? So from analytics we understand that we analyze it. We may analyze it statistically, we may analyze it using machine learning, we may use some other algorithms, we may use artificial intelligence, right? Machine learning falls under the umbrella of artificial intelligence. Artificial intelligence has many wide variety of platforms where we can analytics, do analytics and visualize the results in a way where human can rather more easily perceive it, right? So now once you have done the data and its analytics, now comes the part of prediction. What can be prediction or predictive technologies? Predictive technologies is, suppose you have a vehicle, right? And on this vehicle, let it be let there be a headlight so that we can see that, okay, the car's direction is this one. So in this predictive technology, suppose I just placed one sensor, and this sensor is vibration sensor, right? And let this vibration sensor be fitted inside the engine, right? And this is connected to the transmitter or the sensor node. So this sensor data is being received from vibration data in real time is being captured from the engine mounting and is being sent to controller. Controller is transmitting it on the, yes. Okay, so this sensor value is being transmitted on the cloud, and in the cloud some AI machine or some analytics is being performed. So for example, I may say that usually the vibrations are like this, right? I may say magnitude of vibration, and this is the amplitude of vibration, and after some time this is increasing and these vibrations are rising, right? So what we are seeing, the vibrations are rising, and usually as soon as you start the vehicle there is significantly high amount of vibration. Okay, so this simply indicates that there is some difficulty with the system, and we need to take some corrective measure. Okay, so we can set a threshold where as soon as the vibrations will increase, you will be informed that your vehicle mounting is generating more. This is the similar kind of thing where we deploy pressure sensors on the vehicle wheels, right? We also place vibration sensors even at the wheel, right? So near the wheel axle, so suppose your tire punctures, its vibrations will altogether change, right? So depending upon how characteristic of some data changing will be identified by analytics of that data, and if using that data, if you are able to recommend someone how your machine will behave in coming future, right? And what kind of maintenance is to be done, that will fall under predictive technologies. What kind of prediction are you making? I am connecting things with sensors and IoT or cyber physical system because this is our primary mandate. Otherwise, predictive technologies are nowadays being used to predict how gold rate of gold will increase or decrease, how business market, how share pricing will change. So basically, in the past 1 year, with so many parameters modulating the share prices, different parameters will be considered, and eventually some heuristic, logically convincing decisions would be made, inferences will be taken out to predict whether what would be the rate in the next year, next day, next month, after 10 years. So depending upon how things are changing, if you can do it through some automated mechanism, that will fall under the prerogative of predictive technology, right? So this is how now I understand, you people can understand data analytics, data and predictive technologies. So data analytics and predictive technology is gather data, analyze it, accordingly generate inferences, and accordingly apply, right? So what will be the components of data analytics or data generation? Data will be generated through sensors, right? So from here we start actually the context of data analytics, understanding how data analytics will be done. So let me open browser and show you something which may be rather more relevant. So let me search for iris flower. I will open simply I will open it from Wikipedia. In fact, the same iris data set, as you can see, iris data set is available on Wikipedia, Kaggle, UCI machine learning repository, right? Scikit-learn documentation. Once again, they also, even you will find the same thing in MATLAB. You will find iris dataset in GitHub. In fact, anywhere and everywhere you will find iris flower dataset, right? So this is one of the most classical iris flower dataset, which is very pertinent for anyone, pertinent to anyone who is into data analytics and predictive technologies, right? So here I would say that iris flower data set is basically a multivariate data. Multivariate means there are multiple variables which will change its values. And if I talk about a flower, right, uh, this flower will have different parameters which can be utilized to understand. Okay. Okay. So here you can see, I hope my screen is visible to everyone, right? So you see in this flower, there are sepal, the longer leaves, and petal, which are at the bottom or at the base of the flower, right? So there is petal length and petal width. Similarly, we have longer leaves, so sepal length and sepal width, right? And the kind of flower is versicolor, right? So basically, the flower has three different varieties. One is Iris setosa, another is Iris versicolor, and another is Iris virginica, right? As you can see, Iris virginica has different sepal width, petal width. Versicolor has different, and Iris setosa has another different value, right? And therefore, if I say, so it actually, Fisher announced this data set, he is a well-known biologist. He published this data set in 1936. This was one of the very first widely known and popular multivariate data set, on which hundreds and thousands of papers might have been published. Anyone who starts working, this is in fact, analyzing iris flower data set is a kind of hello world of the data analytics field. Okay, so what this data is, so Fisher generated a data set like this. So he created he measured 50 values each of respective variety of the flower, and accordingly he took 50 different flowers of the same variety iris setosa, 50 different flowers from iris versicolor, and 50 different flowers from iris virginica. He measured its sepal length, sepal width, petal length, and petal width, and these were the values which he got. Right now, whatever he got, accordingly he marked it as iris setosa. This was the variety. So for 50 different types of flowers of category iris setosa were measured, and accordingly first 50 entries are from iris setosa, then next 50 values are from iris versicolor, and then another set is for iris virginica, right? So once we have this data, I would simply look forward to show you how we work at a very basic and primitive level. So I simply copied all the data, and then I will go to my Excel sheet. Where is my Excel sheet? Let me just see. So okay, I have a sheet. So let me paste it somewhere. So I will just paste it all. All right. So now I have the data set order, the number, the parameter values of the data, and then I have the type of the content, right, of the flower and their values. So now if I want to work, so I can call it as raw data. Then I can in fact copy and create a copy of this, and create a copy. So I have, this is curated data. So when I call it curated data, I will change this name as class, right? Let me introduce insert one more column here, so that we are separating the content. So now I have sepal and sepal width. I have the dataset order number, and regarding the class, can I mark iris setosa as class 1? If I can do that, so first 50 entries will be marked as belonging to class 1, right? For the second category, let me mark it as class 2. So this becomes class 2 iris versicolor. Then I go further down, and my third category is this iris virginica. So is it clear to everyone? Please confirm me if it is clear. Okay, very good. So once you have understood this part, now it is the time when we will plan our experimentation. Okay, so how are we going to plan its experimentation? Let me copy this part, the primary data, right, and copy it. So I have copied it from Excel sheet. I will be using a very simple platform is MATLAB. I have my favorite research scholar, Mr. Shivnath Chaudhary, who is working with me in the similar area, uh, pursuing his PhD. So he will demonstrate it on Python. Okay, so for the sake of very simple approach, uh, so you see, uh, okay, now before we reach up to that, one thing we missed was, uh, in fact, this was the curated data, right? From the curated data, I have to generate first content, which will be used for training data, and we will move and copy it to another category as we will call this as rather I should not do this. I will just create another blank sheet called testing data. You see, when you are training a machine learning platform, in fact, I will be typically using artificial neural networks. So if I use artificial neural network, uh, let us, out of these 150 entries, let us take 5 samples or 3 samples from each variety as an unknown sample which we have never used earlier for training the uh, network, right? Our AI model, I will call. So let me just cut it and paste it as here. Similarly, so this was the first variety. Let me take one more sample, maybe any sample. So this one is here. Let me place it here, right? Then let me go down to some other variety, second category of sample. So let me take this. Then let me go further down, take one more sample from category 2. So I have taken this. I will explain why I'm doing this. Okay, and then from the third variety also, let me take some sample and place it. Similarly over here, let me take one more sample uh, and control V. Right. So in this way, I have 6 different types of categories, the 6 different samples belonging to all the 3 classes. Right. So just for the sake of clarity, I will place it here as well. So now you have the data order as well as the testing. Now you see observe one thing. While I did this, I outrightly took these samples out so that I will test my AI model whether it was trained properly or not. So this testing data is my actual data which I will feed to my system to verify whether my AI model has been trained well or not. So of course, all the rows which we have left as blank, we should delete them so that the data is in continuity. So we will delete all the blank rows. In fact, whenever I take some lectures or some training program, usually I prefer to demonstrate this for the sake of convenience to everyone. So now you see, I have training data. With this, we will train the AI model. And then I have testing data with which I will verify whether my system worked perfectly well or not, right? So now I will copy this training data. So you can see that I have 144 entries as training input. So I will call it as training underscore input is equal to, I have just copied pasted. I have placed one semicolon at the end of the instruction so that it is not displayed back on the command window. So I will just enter. So you can see that 144 cross 4 table has been created, right? Now against this I have various classes which I have identified already correctly. So let me copy this also and make it training target. So training underscore TG training target is equal to, once again, this is it. So here I will just paste the targets, and once again I will see that okay, 144 cross 1 matrix has been created as training target. Now once training input and training target has been defined, now we will certainly test the network which we would design. So for testing, let us beforehand itself I can place my testing data. So testing underscore, so ts underscore IP. So testing input is, from where would I take this testing input? From testing data. So testing data is this one. So I will copy it and paste it here, right? So this is testing input. Then similarly for testing target, these are the identified classes to which my data, testing data belongs. So I will copy it and paste it here. So in this way, now I have another thing which is understood as testing target. If my network has been performed well, I will, has been trained well, I will just feed this testing input so that testing input to the trained network AI model, where once this data is fed, it should have capability to give you the output and identify respective classes of respective flowers based on the values which you have identified, right? So accordingly, once this is done, let me come to the network design part. So I will call a toolbox in MATLAB NN tool, neural network toolbox. Once I will enter, so now you can see that the neural network toolbox has been opened. So I will import into this training input as input data. So import, yes, it has been imported. for training target will be imported as target data. So training target has also been imported. I will close it here. Now, once I have received training input and training target, now I will create a new network. So I will call it like this. So I can call it as net1. Okay. So once net1 has been created, or let me write net-1 because probably one network I had already created in the previous history, so it might not uh, counter it. So net-1 is my network. For network type, the convenience with MATLAB is that there are different types of networks which you can choose, right? Usually feed forward back propagation network is very powerful, and I will explain what that is. So to that I will feed input data as my training input, and training target is my target data. The training functions, train LM, train GDM, and mean square error, these are basically training function. I will later on explain how this is if we will have more time. Basically what happens is neural network is a kind of tool, a black box to which we feed training input and expect this network to adjust its internal parameters so that at the output you get the training target. For each single input we have matching target. So first we will feed the first set of training input and training target and fine tune the internal parameters in such a way so that for first input I get first output, the targeted output. Similarly, I will feed next input and receive target by finding the input internal parameters in such a way so that I get right output for the first set as well as for the second set. In this way, suppose in this training program, we have total 144 entries. So 144 times we will fine tune the parameters in such a way so that the outputs are correct. So this is one round of training. Then after this much fine tuning, you will find that still there are some errors in receiving the target, achieving the specified target values. So you will reiterate the same process again and again and again, and until your training performance reaches up to zero value. Technically there should not be any difference between performance versus target. However, usually it doesn't happen, and therefore there is slight difference. So maybe you will go to 10 to the power minus 5 degree of precision for performance versus target. So we will see how it works, right? And while I designed this network, let me take 4 layers into this system, right? So, and in each layer, let me take only four neurons. I will explain what neurons are. Okay, so we will see that. And then you see at the 4th layer, number of neurons you cannot decide. I will explain you how and why. Then tensig is a parameter which is a transfer function by which actually neural networks are trained. Once I have demonstrated and shown you the demonstration, I will explain what neural networks are and what you can understand. For now, you can simply consider them as a black box which we are going to train, right, in MATLAB. So let me view the network if it is all right. So okay, you see there is 4 layers have been created: hidden layer 1, 2, 3, and one is output layer. output layer has only one output, right? Whereas input should be 4, which actually has been put as 144, right? What was the reason? The reason is it is considering that inputs are 44 in parameters, whereas the truth is in our data set we have only 4 parameters to feed: sepal length, sepal width, petal length and petal width. So understanding that this network is wrong, I deliberately did it so that you will always remember what data you are feeding, and if the data has been fed in the right manner with the right sizes. So I will close it. I will go back. I will in fact close this also, and I am here. Now here you see we needed 4 parameters to feed. However, we are feeding 144 parameters, right? So I have to transpose this matrix. So tr underscore ip is equal to tr underscore ip apostrophe, so that it will invert, and I will. So now you can see it has been transformed to 4 cross 144, right? Similarly, training underscore target should also be transposed so that it matches. So training underscore target hyphen, so I will enter it. So now it is 1 cross 44. Similarly, testing input should also be transformed. Oh, sorry. Testing input, right? So we have transformed. So now it is 4 cross 6, right? And then we have testing underscore target is equal to testing underscore target apostrophe, so that it inverts. So now you see, now this has been transformed, right? So once it is so, now I can call NN2 once again and import my training input as input data, import it, training target as target data, import it. Okay, done. Now once training input and training target have been made available, now I can create a new network. Okay, let me call net-1 is my network. As I had told you, we will take a feed forward back propagation network. Input data is training input, target is target data. Other parameters we are keeping the same. You see we have 4 layers, right? It is still so because MATLAB remembers what was the previous configuration, so that's why it is taking the same. Now let me view it. Great. Now you see we have 4 inputs and 1 output. What are the 4 inputs? We have 4 parameters to train: sepal length, sepal width, petal length, petal width. So these 4 are going in, and based on that it has to tell what is the class. So how many classes do we have? 1, 2, 3 are the values, but how many outputs would be there? Only 1 output, right? So in this way now I understand that my network has been very well framed, architected. So 4 inputs will go into the internal part, into the hidden layers. Generally fully connected neural network will receive inputs in each neuron. So whether it was 4 neuron or 5 neuron or 10 neurons, nothing matters. Simply all the inputs will be sent or forwarded to each of the neuron in the succeeding layer. So accordingly, depending upon what size of network you want to take, according to that only you will choose the size of the this. uh, Suppose you have taken a very large network, what would happen? it will not actually reiterate the weights, rather it will utilize only part of the network to remember what was the input, right? So what will happen? While during the training it will give you a very good performance. However, when you will test it, you will find that your network will fail miserably because it has been overtrained. But suppose your network is very small, you have taken only one neuron and only one hidden layer, probably your network will not work because the capacity, the internal parameters are so few that you cannot train the network at all, right? So with this view, now we have seen the network is very good. So I will just create the network, right? So name can only include letters. So I will simply write network one, no issues. And now let's create. Okay, so new network called network 1 has been added to the network or oblique data manager. So now we have created the network. Let's close it. So this is the network which we have got now. Now once we have this network, I will open this because it is the time when we will train this network. So to train this network, I will go into train. What do we want to feed as input? Training input. What do we want to feed as targets? Is training targets, right? Regarding the training results, outputs, errors, it's fine. Let it generate. Regarding the simulation, internally it will do a dry run and verify whether yes, everything has been all right or not. Sometimes simulation, and this is, you may have different varieties of data to design, model, train, adapt, and then finally train. So these are the additional data, but usually even for general purposes, you can utilize the same. So with the same input and target, we have simulated internally. Now we have asked the network to adapt itself. So it will adapt itself now. So adapt the network. Okay, it has adapted now. Reinitialize the weight is internally whatever parameters are there in the neural network black box. These parameters, to give you certain output, they are initialized with random weights and biases. Okay, later on, once I will clear it, I will explain it, and once I will explain it, it will connect you with the whole thing. Now, what are the ranges? Usually the neurons operate within the range of 0 to 1 or minus 1 to plus 1. So whatever are the input ranges, it has to be normalized so that every input has same weight and effect. So we will ask it to set it from training input, set input ranges. So input ranges have been set. So it has normalized your input data. So now every column will have similar importance, right? Uh, so whatever is the internal initial values of these parameters, you can initialize it with some random values. You may revert it again, you may reinitialize, you may do it n number of times. It doesn't matter because internally it is just feeding some random values. Usually some random values would be so good that your network will be trained very quickly, but sometimes these random initiated initialization values may be such that your network would not be able to train. So usually it is just by luck what set of random values you have got during the initialization. So generally people simply revert it, whatever, and then initialize it. Okay, so once you have initialized, uh, let me just go to this. From input to first layer, this is the matrix. From second layer to third layer, third to fourth layer, every layer has been defined in the form of matrix only, right? So once it has been done, let us come to train part. Let me try to train the network. So it is training the network. Here you can see that the performance is 10 to the power minus 4 range. Let me try to train it many more times. So it is getting trained. Let me train until it gets trained to some very high performance value, least precision. So here you see performance is 4.6 into 10 to the power minus 16. Performance is what? It is the current performance of the trained network with respect to training targets. So generally overall average mean squared error values to achieve each of the target output is the average of it is 10 to the power minus 14, which is a very good range. So let me close this training part and I will go to the edit and wait, and simply I will say set weight. So your network weights have been set. So if you would cross check with the previous initialized values, you will find that these parameters have changed. This is what is done in neural network training. So in this way, by using such a very simplistic approach, I have been able to train my network, design my black box, right? So once it is done, even my training part is also over. So my network 1 has been trained. So it is the time to test my network. So I will click on export. What do I want to export? I want to export my network, right? Other things are already available, so no need. So I will just export. So variables have been exported to workspace and my only variable was network 1. So network 1 has been exported. So now you see network 1 has been exported. So our network design part is also over. So I can close it. Very good. So now here you can see at the top in the workspace that network 1 has been created, right? So once network 1 has been created, let me come here and CLC is generally, I prefer to keep my command window clean, so that's why I just do it. Otherwise you may not do it even. So now I have to test my trained network for testing inputs. Testing inputs are those 6 inputs which we had not earlier used for training purpose. Okay, so here we can come and write testing underscore PERF testing performance is equal to, now testing performance will be, now I will simulate my network. So simulate the network performance for network 1, and what are we going to feed to this network 1? TS underscore input, testing inputs, and my network has been closed and I have placed a semicolon so that the results are saved in the form of table, but not in the form are displayed on the command window. If I will not place the semicolon, it will just fill the command window with the output. So testing performance is equal to simulation of the network 1 for testing inputs. I have fed it. So now you can see testing performance matrix has been created, right? So let me open my testing performance and let me also view 2 tables together. So we have the testing target, right? So now everyone please see this closely, that for first 2 input sets were our original first category of flower. So when I fed it, it gave me class 1, class 1. For third and fourth output category of class of flower, it has given me 2 and 2. So it has classified it correctly. The third part is also the category 3 flower, right? So now you can see that my designed network has been absolutely been able to classify it very well, right? So once my network has worked very well, now I can measure or calculate uh, testing or PERF, performance underscore error, is equal to, so this is the TS underscore PERF performance minus TS underscore TG testing target, right? And I will just place a colon, a semicolon, so that now error values have been created. So performance error. So if I open my performance error, now you see here that performance error in case of every single value is now in the range of 10 to the power minus 9, minus 9, minus 8, minus 7, minus 9, minus 9. So your testing performance is also absolutely perfect, right? So this is the time when you can check that your network 1 was designed and it has been trained to classify iris flowers with absolute precision, taking those 150 samples, training samples. We have tested 6 unknown flowers to their respective category, right? So this should be understood by you as what training system is, right? Training a neural or a prediction system is. In this example demonstration, we have actually trained a neural network to classify 3 different types of uh, flowers. Now, the same type of features you can identify for brain tumor images. One of my very favorite student who has also joined this course, Rudransh, he did it for a classification of chest x-rays for corona infection. He has filed a patent for that also. So that thing is very good. The way I identified 4 parameters, he identified maybe 150 parameters from the chest x-ray. Suppose there is some orthopedic accident, some fracture in the bone, right? So can you localize the location and identify where the cracks are and what are its values, right? In fact, let me come to a very simple demonstration of features. For example, let us talk about face recognition, right? In case of face recognition, let me have one face. Let us create a face. I don't know how realistic the face is, right? But let me just try to make him simple, right? So now we have a face. I can identify some exclusive positions, locations on the face, right? So you see I have point A, B, C, D, E, F, G, H, I, J, K, right? Now with respect to these, can I now draw straight lines? Right? Right? So now once I have done this, so I have multiple lines, AB, BC, CD, DE, AF, FI, KJ, JE, and so on. Right? Similarly, I have now angle between AB and AB and line BC, right? So angle between line AB and BC is the angle, say, known as theta 1. Similarly, another angle, say theta 2, another angle theta 3. In this way, maybe you have chosen some 10 different lines and 10 different angles, right? So in this way, now you have length of lines, the 10 chosen lines, and angles between lines, the 10 thetas which we have chosen. So accordingly, length 1, length 2, length 3, length 4 up to length 10. Similarly, theta 1, theta 2, and so on, theta 10. So in this way, you will have number of parameters, right? Now, consider, now this was the case of a human. Now consider an animal. Maybe this is face of a cow. I don't know whether it is a cow or not, but I believe, yes, it is a cow. Now, once again, let me identify similar dots, a multiple. I don't know cow has a eyebrow or not, but had there been a, but at least it might be having some nose, some nostrils, and some values. So now in this, can we draw certain lines in between, right? And when you will draw these lines, you can find similar type of angles, right? Now you see, if your face has changed altogether, for example, this is animal, this is human. I am taking a very simple example so that you can very grossly understand what it means. So what will happen? Whatever is the difference, when you will train it, you will say that for these 20 parameters, the class, for suppose these 100 data, 100 rows of data, they belong to human, and another 100 rows, they belong to animal. So you will have two different categories. Class 1, oh sorry, you will mark them as class 1, right? And here you will mark them as class 2 and so on, right? So in this way, now with this data set, you train the network, and simply after training, take any new animal, any animal, the kind of animal which you have already considered, and then feed those values into the trained network. It will immediately tell you what breed, whether it is a human or an animal, right? One of my colleagues at IIT BHU did a wonderful experiment and a research PhD work. Under that doctoral work, what they did was they trained or did face recognition for large number of animals, typically cows of different breeds. Okay, and against those breeds, rather than giving output as the classes, they quoted what will be its longevity parameter, what would be its milking capacity, what would be its food, what would be its regular maintenance for its healthy living, kind of multiple parameters. So different breeds of cows have different resistivity to survival and performance. Accordingly, what they did, they actually gathered authentic data regarding different types of breeds of cows versus those parameters what they wanted to identify. And accordingly, what happened, they designed a network such that now you show the network of face parameters, and immediately it will identify the type of cow, the breed, and that breed gives you what kind of output performance. Then they translated it into a mobile handset using an app and the mobile camera. And then they went to the for the field trial. So wherever any cow was seen, they simply used to take a photograph of that animal, and immediately on the mobile handset the app used to show that this is this type of animal, the cow breed, and this gives you this much milk per day, these many liters of milk per day, and kind of. So in this way, they created one app for the farmers, so that while they go for the Pashu Mela, where they go, where all the animals are assembled, people, animal sellers gather, and cows are sold. So farmers go there, buy cows, right, by using the intelligent system. So they created a cyber physical system for identification of the animal. Similar kind of thing you can do for dogs, right? Different types of dogs breeds can be identified. So this was just one example using which you can just understand what it means to deliver, right? So accordingly, now I can explain you something very quickly. We had 4 input: sepal length, sepal width, petal length, petal width. This went into 4 neurons in first hidden, 4 neurons in second, 4 neurons in third. Then in the fourth layer, there was only 1, right? Rather, it was not this. Rather, we had 1 more, and then, right? These are input terminals. In fact, these are also neurons, but they are not considered as neurons. However, now they will feed the data to each of the succeeding neuron, right? Just see how am I drawing. This is called fully connected neural network, where each input is getting into next output, right? So this is the weight matrix 1 1 and as you had seen in the trained MATLAB network, right? So B1, so W1 and B1. So this is the weight matrix and the bias matrix. Okay. So input is multiplied by weights plus added with the bias to provide output for the next layer. Once again, output of the next layer goes into each of these succeeding networks. Okay. In this way, this is the second layer. So MATLAB has shown you already W2 and B2, weights and bias matrix. So this is multiplied by W2 and added with B2, gives you next level of output. Now with the next level of output, now we have these outputs. These are once again fed to each of the succeeding layer. So once again it is multiplied and so on. So what we meant is input was multiplied and fed into artificial neural network, your AI model, right? And so we had 4 different matrix multiplications to finally get you the output, right? So in this way, we had 4 input parameters: sepal length, sepal width, petal length, petal width, and we received the output as class, right? So type of flower. So this could be identified. Now, once you have done this, now you will take a microcontroller. In real time, you feed this data and immediately it will give you the output, right? So for that, this AI matrix multiplication will be done here, right? In this way, a real-time system can be created. This is a real-time system. If this data goes into cloud and this AI model, if this goes into the cloud and your AI model is placed here, this matrix multiplication, if this is performed in the cloud, this is normal cyber physical system, a standard cyber physical system. So depending upon if you have local system, right? So this is an intelligent sensor system. So I will call it as intelligent sensor system, which has AI, है ना, with inbuilt AI engine. Now more, so this may be microcontroller or microprocessor. So whether we have a microcontroller or a microprocessor, if you can transfer AI engine into this, a microcontroller will have much limited capability to actually work. However, if it is a microprocessor, it will have rather more capability to do the multiplication and other things. So this you will understand as edge computing, right? So if you are doing computation on the edge, this is it. You will place AI engine on this. Otherwise, you can do the AI data analytics and prediction on the cloud, and you will understand it as a standard cyber physical system, right? So sometimes we do both the things, so we create hybrid system. In edge computing, part of the features are filtered. It is not completely processed, but key features are only forwarded to the cloud. So partly edge computing has helped, rest your cloud computing will help. In this way, a very good system, very efficient system can be designed. So with this, I will come to close the talk. So this was all about data analytics and predictive technologies for cyber physical systems, right? So this is how a real cyber physical system can be designed. This was a very brief, simplistic and very basic approach for you to understand how basically sensors, AI, computation help us to create a cyber physical system. Okay, uh, dear all, thank you. Thank you for the patient hearing. We can take some questions now. If we have some time quickly.
Yeah, any question from audience side?
Yes, excellent question, sir. Professor Rajput, sir, just you were talking about cow and you talked about the Mela, Pashu Mela, and you said that on the basis of this device, on the basis of this, one can be able to know about the milk production, how much milk this cow can give. So, is it possible that by this device one can develop something so that it can be detected that yes, this cow is having this kind of problem? Is it possible? Or you also talked about COVID and one of the student has developed something about the respiratory system and all. So, is it possible, sir?
Yes,
Is there any possibility? Yes, please, please.
This is why I shared with you all that this was a doctoral work, and they came up with a cyber physical system on the mobile handset. They created a mobile application which had the AI engine inbuilt, and it used to identify a specific uh, tool to identify what kind of breed will give you what kind of milk. It's actually, it so happens, when the farmer goes into the Pashu Mela, he doesn't have a mechanism by which he can quickly know. Now the seller tells him that this is this breed and this will give you 20 liters per hour of milk, right? I mean, they exaggerate and they mislead. There is no mechanism whereby you can actually stop it, right? Or how to cross check. So there is one standard mechanism which can be used. So this was just one application. There may be number of things. You see, wherever a human brain can actually understand and identify some anomaly, exactly similar thing you can do. Okay. Okay, there is one question. Sir, can we, yeah, thank you. Sir, can we use this for infrastructure classification for particular area? Yes, of course. What kind of data can you generate on that? If you can unmute Sakshi, we can just listen your question, and you may explain. What kind of data will you get? For that data, how you will identify or train your system based on that? Yes, of course we can use this. Okay, generally it so happens that remote sensing data is captured from the satellite in high resolution, and whatever data is captured, based on that we train a neural network for land classification purposes. So whether this is a green field or a farmland or some concrete building has been created, what is the size of the building, whether this is a large mall or something, kind of things are uh, can be classified. Okay, so now I can see with us Prashant sir is has joined. Hi Prashant.
Sir, just a question remaining.
Yeah. Okay, please.
Sir, is it possible to classify the storage in a large infrastructure, sir? Floors in the large infrastructure. Is it possible to classify?
Floors, how do you want to classify? What parameters would you use to classify your floors?
Sir, like if you want to deliver something at different floors, how we can give order that the drones can supply these things at the particular floor?
Right. So drone is computer vision based, and what the drone will be, for example, this is a apartment, right? So in the apartment, we have multiple floors. So either drone will take a long image, an image from far away place, and it can take the complete snapshot of the building. It can identify, the AI engine will immediately identify where the windows are, and accordingly it can identify various floors automatically, right? And
Yes.
yeah, so you will have to define it, how you can identify, and then where do you want to deliver. Okay, some
Yes, sir.
lobby or something you have to identify, but of course you can do that.
Yeah. So rather wasting time, I think we already got another presenter right now. Okay, so let me thank to sir, Dr. N.S. Rajput sir. So you started from very basic application and moved toward the neural network, then giving direction to the coronavirus, cow living, age, and cloud computing, and everything was very fantastic. Sometimes it's become very difficult to get a real-time application which you can elaborate in such a nice manner, and moving toward the slowly towards the complicated problem, right? Everything was very well settled, actually, sir. So thank you so much for giving such a nice talk.